working as assistant professor in the Department of Civil Engineering. Today, my lecturer topic is design of steel structures, sir. So I am very much thankful to CRI and principal sir, director sir, for giving this opportunity, sir. Shall I continue, sir? Ah, okay, sir.
Sir, make it full screen, sir.
Okay, sir.
Yes, sir. Okay,
So,
sir.
is it visible, sir? Slide?
Yes, sir. It's visible, sir.
Okay, sir. So steel is a ductile material. Steel has high strength per unit mass. Actually, steel steel structures have the large column free structures. So there are so many uses for these steel structures. Roof trusses for factories, cinema halls, auditoriums. For example, our uh, bus stations also made by the roof trusses and columns to cover the entire platform in railway stations also, and bus stands also. The transmission towers for the microwaves also, and electrical power, water tanks, chimneys for factories, whatever it may be. So many structures are made by the steel. Okay, sir. Next, advantages and disadvantages of steel. So there are so many advantages are there. Steel has the higher strength per unit mass compared to other building materials such as uh, cement, RCC. Compared to that materials, steel has higher strength per unit mass. Hence, even for larger structures, the size of steel structure element is very small. Here, steel structures can be strengthened at any later time if necessary, if needs just welding additional sections. Material is reusable. Suppose if the entire structure is collapsed, then also the material also reusable. It has assured quality and higher durability compared to other materials. Steel structures can be strengthened at any time if necessary. It needs just welding and additional structures. Anytime it can be strengthened, not for an. Okay, sir. A material is reusable for at any time. At any time, the material is the reusable. The joints are taken care. It is best water and gas resistant structures also. So, as well as disadvantages also there, sir. Advantages as well as disadvantages also there. So disadvantages are corrosion. Disadvantages are corrosion. If the steel is put into open air means it will get corrosion. That is the main problem. Maintenance cost is very high. That is the problem for the women. Since it needs paint to prevent corrosion also. Steel members are very costly members. That is the problem for steel. Okay, next one. There are types of steel, sir. So many types of steel. So depend upon the percentage, carbon, manganese, depend upon percentage. So many steels are there. Chrome, nickel, impart corrosion resistance property to the steel. Addition of small quantity copper also increase the resistance to corrosion. For example, ordinary steel, which have the more carbon content. Second one, manganese also there. The properties of steel. Properties of steel required engineering design may be classified as physical and mechanical properties. Physical properties are density. Density is 7,850 kg per meter cube. Modulus of elasticity 2 into 10 to the power of 5 Newton per mm square. Poisson's ratio is 0.3. Modulus of rigidity 0.769 into 10 to the power 5 Newton per megapascals, or 1 MPa is equal to 1 Newton per mm square. 1 megapascal is equal to 1 Newton per mm square. So the thermal coefficient of expansion also there, that is 12 into 10 to the power minus 6 degrees of centigrade. So here Young's modulus of steel is, that value is always constant, that is 2 into 10 to the power 5 Newton per mm square. So Young's modulus is the ratio of stress to strain of the material, that is always constant. This one, Poisson's ratio, also constant. Okay, sir. Next. So there are, I already told, there are so many grades of steel. E250. 250 is belongs to E. E followed by 250. That number is belongs to strength of steel in tensile strength. Strength of steel for tensile strength, that is 250 Newton per 250 megapascals or 250 Newton per mm square. Here E 250, that is thickness less than 20 mm is belongs to 250 Newton per mm square. Between 20 to 40 mm thickness is 240 Newton per mm square. It is for 40 mm means 230 Newton per mm square, sir. Next, E250. E250B. E250B grade is, it is thickness is 20 mm, less than 20 mm means that is 250 Newton per mm square. It is in between 20 to 40 millimeter is 240 Newton per mm square, and it is 40 mm means 230 Newton per mm square. Next, so many grades of steel, sir. Okay, that I have. So generally, there are so many steel sections generally used for construction purpose. Those are rolled steel I sections, rolled steel channel sections, rolled steel angle sections, steel T sections, steel bars, steel tubes, steel plates, steel flats, and sheet and strips also, sir. Next, for example, suppose rolled steel I section, that is abbreviation is ISJB. ISJB means Indian Standard Junior Beams. Indian Standard Junior Beams. ISLB means in Indian Standard Light Beams. ISMB Indian Standard Medium Weight Beams. ISWB Indian Standard Beams. Indian Standard Heavy Beams. Depend upon the depth and weight of the section, these are different. Indian Channel Junior Beams are different. Indian Standard Light Beams are different. Indian Standard Medium Weight Beams are different. Indian Standard Wide Flange Beams are different. Indian Standard Heavy Beams are different, depend upon the depth and weight of the section. Okay, sir. So this one is a I section. I section is belongs to three components. One is top flange and bottom flange. The junction between these two is web, sir. That is web. The junction between these two, top flange and bottom flange, the junction between two is web. There are three components. Next, suppose I already told these sections are belong to abbreviations. ISWB 600 at 1.423 kN per meter. Here ISWB followed by the number 600 is belongs to depth of the section, and 1.423 is the weight of the section. Same section is same, but depth and weight are the different. ISWB 600 at 1.312 kN per meter. Here also depth is same and weight of the section is different. Same ISWB Indian Standard weight beams are. Next one is Indian Standard Heavy Beams, ISHB. That is depth of the section is 400 mm and weight of the section is 0.855 kilonewton per meter length. Last one is Indian Standard Heavy Beams. That is depth is 400 millimeters and weight of the section is 0.907 kN per meter. Next, sir. Next, rolled steel channel sections. Channel section. So beam sections are over. Go to the channel section. Channel sections also. The sections are classified into following four series. Same abbreviations are followed. ISJC Indian Standard Junior Channels, Indian Standard Light Channels, Indian Standard Medium Weight Channels, Indian Standard Special Channel. Light channels. So the meaning is light means it is the weight is very lesser compared to others. Indian standard junior channels also. Indian standard medium weight is somewhat better compared to these two. Last one is Indian standard special channels. So you just observe the channel section. The top component is a top flange, bottom component is bottom flange. The junction between these two is web. Okay, sir. Here also same. Here also same. The rolled channel sections are designated by the series to which they are belongs to, followed by the depth in millimeters and weight is in kN per meter. For example, ISMC, Indian Standard Medium Weight Channels, followed by the 300 number is depth of the section in millimeters and weight of the section is kN per meter, that is 0.531 kN per meter. Next, Indian Standard angle sections. Angle sections are classified Indian Standard equal angles, Indian Standard unequal angles. Indian Standard equal angles, suppose the section is equal means that is equal angle. Here angle section or L section both are same, sir. You just observe here L section or angle sections. These sections are used for building constructions. Here Indian Standard equal angle, that is ISA. Indian Standard equal angle is ISA. Indian Standard unequal angle also ISA. So how to consider equal and unequal? Both the components, both these are two components of this. One is that components are legs. If it is longer means that one is longer leg. If it is shorter means that leg is belongs to shorter leg. So ISA 150 150 12 here ISA 150 into 150, that is belongs to equal angle section. Length into width is equal and 12 mm thickness, that is the equal section. Indian Standard angles 150 into 115, that is unequal angle. So thickness 10 millimeter. That's why equal and unequal angles. Equal means both the legs are equal. Unequal means one of the leg is longer leg, remaining leg is shorter leg. Okay, sir. Next one. T sections also same. Generally, T sections are belongs to 5 categories. That is ISNT, Indian Standard Normal T bars; ISHT, Indian Standard Heavy Flanged T bars; Indian Standard Special Legged T bar, that is ISSLT; Indian Standard Light bars. Indian Standard Light bars are Indian Standard Light T bars, ISLT. Next one is Indian Standard Junior T bars. Next one. Here also there are in T section there are two components. One is top flange. Next one is web section. So rolled steel sections are designated by the series to which they are belongs to ISNT 60 at 53 Newton per meter. Same ISNT followed by the 60 is number is depth in millimeters and 53 Newton per weight is 53 Newton per meter is the weight of the section. Next, according to IS 808-1984, the following T sections are also adopted. Now, Indian Standard Deep Legged T bars, ISDT; Indian Standard Medium Weight T bars, ISMT; Indian Standard Sealed Heavy T bars from I sections, that is ISHT. Next, so as well as steel bars also there. Steel bars also very much useful to the steel constructions, that is ISRO, Indian Standard Round bars, ISRO. Second one, Indian Standard Square bars, ISSQ. Here also same as followed by designation, Indian Standard Steel bars. So bar is which is having diameter ISRO, Indian Standard Round bars, 16 is 16 millimeter diameter. ISRQ, Indian Standard Square bars, that is a 20 in 20 mm dia. Next, steel tubes now generally not used in building constructions. Next one, flats, steel flats. Steel flats are steel flats are useful, also useful in the constructions. Flat differ from strips in the sense that the thickness of flats 5 mm onwards and their width is very limited. So width is steel flats, which is the width 12 millimeters, 16 millimeters, 20 millimeters, 25, 32, 40, 50, 63, 80, 100, 125, 160, 200, and 250 millimeters in millimeter. These are available in the market. Thickness also same 5, 6, 7, and 5.5, 8, 9, 10, 11, 12, 14, 16, 18, 20, 22 millimeters only available. So the designation also same as well as 80 ISF, 80 Indian Standard Flat, Indian Standard Flats, 80. 80 mm is 80 mm is the wide and 10 millimeters is thickness. So 80 mm is the wide of the section, 10 millimeters is the thickness of the section. Next, 1 minute, sir. So steel structures can be analyzed by two methods. One is working stress method. Second one is limit state method. So generally, most of the countries are followed by the limit state method, sir. Compared to working stress method, limit state is very suitable. That's why so many countries are followed by the limit state method. So many countries are followed by the limit state method only. So compared to working stress method, limit state method, there is some differences there. Here, our loads are belongs to factor loads. Our bending moment is belongs to factor bending moment. Our shear force is belongs to factor shear force. How to convert the load into factor load? That is important here. That is the specialty of the limit state method. So here load factors are applicable in the limit state design. So 1.5 is the load factor. Load factor is applied to the loads. That is, load means, suppose load is 50 tons means load factor is applicable. That is 1.5 into 10 tons. Then working stress method, same load is applicable. There is no load factors for loads and shear force bending moments. Same load we have to take in limit state method. Load factors and form factors also applied to the loads, bending moments, and shear forces. 1 minute, sir. So before going to design the steel structures, there are so many loads are to be considered first. Otherwise, it is very difficult to analyze the structures. First one is dead loads. Dead load means it is the self weight of the structure. Means it is the own weight of the structure. Next one is live loads. Live loads mean are the temporary loads. Wind loads, earthquake loads, erection loads, accidental loads, and secondary effects are to be considered. So dead load means it is the self weight of the structure. It is a permanent construction of the structure, and live loads means these are the temporary loads. Live loads means vehicles are passing on the bridge means that loads are the live loads, and bridge structure load is the dead load, that is permanent load. So many loads are to be considered. 1 minute, sir. So I already told there are two methods for analyze the any type of structure. One is limit state method. Second one is working stress method. Here, IS 800-2007 IS 800-2007 code is supports the limited design, and IS 800-2004 code is support the working stress method. These codes are to be revised up to 2007. That's why IS 800-2007 supports the limited design. Next, working stress method. Actually, here IS 800-2007 is supports the limited design. The permissible stress is calculated by yield stress to factor of safety. Formula is same for both the methods, working stress as well as limit state method. Limit state method. Here, load factors are applicable to the limit state design, and working stress method same loads are to be taken, same bending moment are to be taken, same shear forces are to be taken, but in limited design, the loads are to be converted into factor loads, and shear force is converted into the factor shear force. Bending moment is converted to the factored bending moment. That is the difference between limited design and working stress design. So wherever working stress design is not implemented, means it is very difficult to implement it, means in that circumstances only limited design is to be applicable. Wherever limited method implemented is difficult, means in that circumstance only working stress method is to be possible. So advantages of the working stress method is this method is simple and reasonably reliable. As the working stress are very low, the serviceability requirements are satisfied automatically. Limited design, it is a comprehensive method which takes care of the both strength and serviceability criteria is taken into account. Now most of the countries are followed by this method. IS 800-2007 suggests this method, and steel tables are also to be followed. We have to select the section from steel table based on the area of the section. The limited method, the strength of the structure till the formation collapse, the mechanism is formed to take the care of uncertainties involved in the analysis. Design and construction code suggests the increased working loads which are based on the statical analysis and known as characteristic loads. I already told in limited design, load factors and partially safety factors are material to be applicable. Load factor is 1.5, 1.5 is to be taken. So 1.5 is applied to the loads, bending moments and shear force, as well as partial safety factors also applicable to the loads, shear force and bending moment. Generally, we have to select the section, steel section, either it is channel section, I section, T section, or selected from the steel tables based on the area of the section. Area of the section. Any structure going to analyze means, so loads are to be, I already told, loads, dead loads, live loads are to be considered. In some countries, dust loads are to be considered. Why means dust is dust is automatically deposited on the structure, means that also considered a load. Dust also a load on the structure. In some countries also, crane load also to be considered. If suppose crane is working on the structure, means crane loads are also to be considered, as well as dead loads, live loads, and wind loads. Okay, sir. Any queries, sir?
Thank you, sir. Thank you very much. I
Okay.
request the
Thank you, sir.
participants, if you are having any queries, you can ask, sir.
Any queries, sir?
Thank you, sir. Thank you very much for your presentation.
Okay.
And thanks all
Thank
the
you, sir.
participants.
Thank you, sir. Thank you for
Okay.
Venkatarayan, sir, Akhijar, sir, and Mohan, sir. I am very much thankful to Mohan, sir, also for giving this opportunity, sir. Okay, sir. Shall I leave, sir?
With this, we end the session.
Mm.
Okay, sir. Thank you.
Okay, sir.